Alright, algebra classes, this is Mr. Kim. Like I said, I'm going to make sure that you guys get this lesson today. So, fourth period especially, since you weren't there at the beginning at all, and maybe even third period, because we didn't have that much time. If you're looking at this video, I'm going to go over the main points, and then toward the end, I'm actually going to go through several problems so that you know how to do it. Just an overview, problem 9.1, the first problem is just solving these equations using the zero product property. Okay, so nothing special. We're not doing anything particular that we haven't done already. You're just setting these equations equal to 0 and you're solving. So find x. Okay, so that's that. I'm not going to go through these. Let's go to number 2. Number 2 says, let's use your graphing calculator to verify your solutions to the original equation in problem 1. So let's verify the first one. So if you look back at number 1, you'll notice that there is a 3x squared plus 4x minus 6 equals 9, right? Equals 9, and then the second equation, or sorry, problem 2, just basically doesn't have the 9, and they just want you to graph this equation. Okay, so basically they say, where on the graph would you look to verify your solution? In other words, where is this equation going to equal the number 9, right? If you don't see that, let me go back here. The equation equals 9. So we want to verify where this parabola equals 9 for the y-coordinate. Alright, so we're going to graph that. So once again, 3x squared plus 4x minus 6. Here we go, and obviously I have it prepared. So here's the equation, right? And you'll notice that there's a y-intercept down over here. And that's negative 6, and that matches the y-intercept here on the c term because it's a standard form. You notice the x-intercepts, they're going to be pretty not nice, and they're not going to actually match the first problem. And that's because we're not solving this equation, okay? We're not solving this equation for x. We want to solve this equation for x when y equals 9. That means we need to find some y-coordinates up here where y equals 9, and these are what we're talking about. If you notice, y is 9.005 here, and there's also another 9 on this side. Right? So obviously I'm not being very accurate. Oh, there it is. So negative 3 comma 9 is there. Let's see if I can do that over here. It's not working out so well. So let me actually show you a quick way, and that is to actually type in y equals 9 over here. So that's exactly what I'm going to do. Y equals 9. So y equals 9 is a horizontal line, and it's going to intersect on my parabola at 2 coordinates. So then when I click on those, there's that negative 3, 9 one more time, and there's basically 1.6 repeating, or 1 2/3, or 5/3, right? And that should match the x-coordinates that you got in the very first problem before this. Okay, and so that's kind of what they wanted you to see, so I'm kind of demonstrating it for you. If you go back to problem 2, you're just going to answer these questions. Okay, so done there. If you need to see this again, rewind or scoot it back, watch it again. We're going to move on. Problem 3, this problem is about completing the square. So we're going to revisit completing the square today, especially because we're going to make it a little bit more complicated. I call it completing the square part 2, or sometimes I call it completing the square part hard. In other words, this is the hardest type of completing the square. The easiest type is when we do not have a value in front of the x squared. And basically when a is 1, it's nice and easy. So what we're going to do is kind of bypass all this work, because we're not using algebra tiles, and we're going to do basically part D here. Okay, so we're going to complete the square and solve for x. Alright, complete the square and solve for x. So let's go back to this problem, x squared minus 6x minus 9. And let me get some room here. Let me see the equation again. I want to make sure x squared minus 6x minus 1. So I almost got it wrong. Alright, here we go. So x squared minus 6x minus 1 equals 0. We're going to complete the square like we've done before. That means we're going to create room for the new c term. So that means x squared minus 6x minus 1, and underneath in a different color I'm going to make some room for my new c term. So if you remember from our last unit, finding the c term right here is basically taking the b term, negative 6, dividing it by 2, and squaring it, which comes out to a 9. So that's our new c term. We're going to use the idea of a zero pair. We're going to add 9 here, and because we added 9 here and we're on the left side of the equal sign, we have to subtract 9 to make a zero pair. In other words, we're adding nothing technically, but by adding nothing that are two opposite numbers, we kind of create something new. So let's go ahead and finish completing the square. This is going to be x minus 3 quantity squared. This is going to be minus 10 equals 0. So part 1 done. They said in question D, it said complete the square, and then it said solve. So solve means we're going to solve for x. In other words, find the value of x. Since this is squared, you know we're going to get two solutions. And we do that by first moving this term to the other side so we can square root. All right, so x minus 3 squared equals 10. Square root both sides. And we've done this before, but just in case you forgot, the square root and the square cancel each other out. So now we have x minus 3. Actually, let me get rid of the parentheses. X minus 3 equals plus or minus radical 10. Remember, whenever you take the square root of a number inside an equation, right, equal signs, you're using the positive and negative values of that square root. Since we don't know the exact value of square root of 10, right, it's going to be bigger than 9, so 3 point something, we can represent it as plus or minus radical 10. So let's solve for x by moving the 3 over to the other side by adding. If I add 3, I get x equals 3 plus or minus radical 10. And this is the proper form. Let me kind of give you the general form. We say a plus or minus b, sorry. Actually, let me forget that. I'm thinking of something else. So we put the integer first and then plus or minus the radical. All right, so integer plus or minus the radical. So there's the solution for x, and that all started with this little equation up here. Remember, we completed the square, then we solved for x by moving this minus 10 to the right side so that we can get x isolated and made it all the way down to this. Okay, so this is going to go away. Pause the video if you need if you need this up still. And that's question D. So now let's go to E. E says, to make sense of the x-intercepts in D, what we just solved, you probably wrote your solution as a decimal. We didn't do that because I didn't want you to. Square roots that are not perfect squares, just like radical 10, we'll call them irrational numbers because they cannot be written as a fraction and they cannot be written as an integer. Remember, fractions can repeat, like 1/3. 1/3, if I, let me write that down. 1/3, if I write that, that's a repeating decimal forever. That is rational, and it's rational because it can be written as a fraction. But certain numbers can't be written as fractions, like the square root of 10, and so we call those irrational. Let's continue reading. When you write a square root as a decimal, you have to round, so it is called approximate decimal form. So when you take the square root of 10 on your calculator and it gives you 3 point something, that's the approximate form because it never ends and it doesn't repeat. When you use the square root symbol, you are using exact or radical form. So the answer we had, I don't remember exactly what it was. Was it 3 plus or minus radical 10? Or negative 3 plus or minus radical 10? I don't remember, but there was a radical 10 in there. So we call that exact form or radical form. It's exact because we don't have to round anything by leaving it as radical 10. And obviously it's called radical form because we have a radical in there. So now you guys try this one, okay? I'm going to do that with you as well, just to make sure you know how to do it. We're not going to check your answer by graphing. I mean, you would just graph it on Desmos or something. Let's just solve it. So let's just get down to it. Here we go. X squared minus 4x, x squared plus 4x minus 5 equals negative 2. Now, you might be confused. What should you do with this negative 2? If you already have a number there, just kind of leave it. In other words, don't bring it back over. Just leave it over there. You just focus right here. Remember, we have to create room for a new C term. It might make you more confused if you actually bring it over here because we're eventually going to have to bring it back anyway. So you're just going to let the negative 2 hang out because before we had a 0, right? You're normally used to seeing this, right? Now we just have a negative 2 there. So don't let that fool you, it's just hanging out. So treat it like if it was a 0. So x squared plus 4x, we're going to put some parentheses here, create some space for c. Minus 5 goes outside of the parentheses, it's not part of the perfect square. And we're going to create space for the 0 pair, and then we just keep the negative 2. Take half of b, square root, take half of b and square it. So 4 divided by 2, 4 divided by 2 squared is another 4. We're adding and subtracting. Again, that's a 0 pair. So factor x plus 2 quantity squared minus 9 equals negative 2. We want us to solve for x, right? It said build the equation. We're not using algebra tiles. Use Kier's method to complete the square and solve. So we just complete the square. Let's solve this guy now. We're going to move the 9 over. So x plus 2 quantity squared equals 7, right? If I add 9 over here, right, that's a 7. And then I'm just going to square root. Don't forget the plus or minus part. And finally, move that 2 over. I ran out of room here, so let me move it up. X equals negative 2 plus or minus radical 7. Again, this is called radical form or exact form. Right? Let's write both of those down. Exact form, radical form. And especially on your tests, when I don't let you use a calculator, this is what I'm expecting. Right? So you won't have to know how to do the square root of 7 in your head. You won't have to memorize them. Just write your x-intercepts like this, and I'm good. Okay? So this is basically what we're doing. Okay, you guys already know how to complete the square. And the next question, the last question, you're going to get some problems that look a little different. In other words, we're going to have a number here, and we have to deal with that. So this is the hardest part of the lesson, and so this is going to take the longest. So gear up, here we go. Right, I'm not going to do number 4a with you because you should be able to do this one. There's no a term, right? And it pretty much looks like the last problem we just did. So you're on your own there. You make that happen. I'm going to focus on b. But in order to do b, let me give you an easier looking problem. Okay, so I'm going to create a new problem for you that I want you to do. Let's call it a.5. Just making it up. In between a, in between b. And here's the brand new problem. 4x squared minus 24x minus 4 equals 0. So let's start there. Okay. What we're going to do is we have to, rule 1 of completing the square, let's start here. When you complete the square, and I'm going to call it CTS for short, complete the square, here's the biggest rule. A must equal 1. Okay. In other words, to complete the square properly, you have to make the a term equal 1. Problem is, in this question, a.5, the a value 4 is not 1. So the only way to make it equal 1 is to GCF the a term. In other words, we have to pull out the 4 so that a is equal to 1. And this is where it gets confusing. But if you remember everything we've done for problems that look like this, it's actually going to make some sense. So because when we complete the square, we only use the x squared minus 2x, right? And this negative 3, or this minus 3, we would kick out of the parentheses, right? It wouldn't be involved. We're going to do the same thing here. So we're going to create a parentheses, okay? Now I'm going to do this step by step, so it might look very detailed and long, but I'll show you a quicker version when we do this problem. So we're going to put 4x squared minus 24x here. Okay, leave a space for c, and then we're going to put the minus 4 here, leave a space for the 0 pair of c, and leave 0 on the right side. So we're going to continue on like we normally do. Now, stray mark. I did say we have to move or take out this GCF. So notice that 4 and 24 have the number 4 in common, and it kind of works out that way. We did that on purpose. So what we're going to do is GCF the 4 by pulling it out, and now we have x squared minus 6x. And then I'm just going to copy everything else. And let's go ahead and put a plus sign here and a minus sign here, because we know that's going to be a 0 pair. So here's where it gets tricky. It's not finding C that gets tricky. It's actually after you find C, what do you do? Because most of you probably think, oh, this is easier, Mr. Kim. We're just going to plus 9 minus 9. And that's not the case. All right? We're going to plus 9 here like we normally do because half of negative 6 squared, right, is negative 3 squared, which is 9. So we're going to place the 9 here. Now here's the tricky part. Normally we wouldn't have this 4 here, so I'm going to kind of cover it up. Normally we wouldn't have it here, and if it wasn't there, yes, you would put a minus 9 here because we want to zero pair that out. Problem is we do have a 4. So the actual value of this term is not 9. The actual value, some of you might have gotten there, is actually the distributive property of 4 times 9. So this value is actually 36. Okay, and the reason that is because we already started with the 4 in the problem. We can't just make this number disappear and go away, and we don't want to use it anymore. We have to preserve it. We have to keep it. So 4 times 9 is 36. So the zero pair of 4 times 9, right, is negative 36. Right, 4 times 9 is positive 36. So now this number has to be negative 36. But let me put it another way. We created a 36 in this problem by putting a 9 in here, right? Because the original numbers were 24 and 4. We shrunk them down to 1 and negative 6. But they still, once you multiply them back in, still have a value of 4, still have a value of negative 24, which means this is now really a value of 36. So we have to zero pair a positive 36, which is negative 36. And that's the confusing part for most kids. It's switching your mind from being used to problems with a 1x squared versus a 4 or a 10 or an 8x squared. In any case, if this part made sense, great, you're ready to move on. If it didn't, you need to rewind or watch it again, basically. Rewind, talking like an old man. Here we go. So let's continue to complete the square. Keep the 4. We know this as a perfect square is x minus 3 quantity squared. That's going to be minus 40. Equals 0. So from there, we are going to now solve for x by moving the 40 over, or the negative 40 over. And this might look a little bit more familiar now. We're going to divide by this 4 to isolate the x term. So we get, I'm going to move over to the side here, x minus 3 quantity squared equals 10, and you can guess by now how we're going to solve it. We're going to square root both sides. X minus 3 equals plus or minus radical 10, so therefore x equals 3 plus or minus rad 10. Okay, so I know I spent a lot of time up in this section, but you really need to understand that part, because if you don't get that part, what you're going to do on your test or a quiz or whatever is you're going to do this part. That most kids understand this GCF part to pulling out the 4, but then you minus 9 here, and if you minus 9, that's going to mess up your final answer, right? Because instead of negative 40, you're going to get negative 13, and that's not correct. In any case, that's how you do this type of problem. I gave you a brand new one, 8.5. Let's go and finish problem B now. If you want, pause my video, right? Work ahead, and then see if you can get rid of, I'm sorry, not get it, see if you can get it right, and then play my video, and see if your answer matches up with mine. Now, quick thing, we do have a number on the right side here, so remember what I said previously. If it's already on the right side, leave it there. Just focus on the left. So on this problem, you would leave the 1 and just work on this left side. So what we're going to do is just take out the GCF on letter B by pulling out an 8. And so I did tell you I'm going to take a shortcut. So I'm not going to write all the steps, I'm just going to do the most important stuff. I'm going to take out an 8 and notice that that's going to divide in nicely. So 8x squared plus 5x, there we go, it's an odd number now. Okay, and I'm going to create some room here. Since I didn't have a C term here, like this previous problem, or even the 8.5 that I created, I don't really have to worry about a number on the outside. I just have to worry about my zero pair. So I already know that's going to be negative, this is going to be positive, and then I've got my 238 on the right side. Okay, so what we're going to have to deal with is this odd number, half of 5 squared, which is 25 over 4. Let me use a different color to kind of make it more obvious. Then minus 25 over 4. So we're going to have to deal with this. It's going to cause a problem, and that's just the way it's going to be. Remember, there we go, I messed up. I got ahead of myself. If you didn't see what I did what I said most students would do, or some students would do, is that instead of multiplying 8 times 25 over 4 and figuring out what the value of the zero pair should be, I just assumed 25 over 4, negative 25 over 4. So There we go. It even happens to the best of us. But I caught it. Yay for me. So the real value of this zero pair is going to be whatever 8 times 25 over 4 is. I know most of you can do it in your head, but just in case it's a little overwhelming, right? Let's just do some mental math here, right? That's going to be 50, right? So the real zero pair value is 50 because negative 50 because 8 times 25 over 4 is 50, so we have to subtract 50 to maintain 0. All right, so let's complete the rest of this problem. We've got 8x plus 5 over 2 quantity squared minus 50 equals 238. Remember, we're going to solve for x, so I'm going to move this 50 by adding it. So 8 quantity x plus 5 over 2 squared equals 288. And at this point, if you want to change that to a 2.5, you can. It doesn't really matter right now because we're going to divide by 8. And fortunately, 8's going to go in nicely to 288. Just working it out here. Let's see, 36. Let me verify. Yep, there we go. So I'm going to square root both sides. Turns out the square root of 36 is a perfect square. So x plus 5 over 2 equals plus or minus 6. At this point, if you want to change that to 2.5, I would. It's easier to add the decimal to the 6 than to add 5 over 2. So let's over here on the left. X equals negative 2.5 plus or minus 6. So the final answer is x equals 5.5. No, I'm having some trouble here. 3.5. And x or x equals negative 8.5. And that's just basically splitting up the plus and splitting up the minus, right? Negative 2.5 plus 6 is 3.5. Negative 2.5 minus 6 is negative 8.5. All right? So if you need to watch this lesson again, please go back and watch 8.5 and this question B up here. But in any case, this is completing the square part 2 or completing the square part hard. Anyway, that's it. If you have questions, please email me or see me again tomorrow, and hopefully we can get this all straightened out. Good luck, and make sure you do the homework.